All right, so I'm just gonna riff on this video here because I don't know exactly where this is gonna go, but I'm kind of inspired, so let's do this. I'm Sean, the owner and lead tutor of Math Swap Tutoring. I am also of the background of electronics engineering, and I want to talk a little bit today about why math is so cool. I took a liking to math in school. I did fine in all my other subjects, but math is different. Because if you really think about it, if we can get past the whole just kind of like getting a grade kind of aspect of school math, you can do stuff with it. So the way I saw math in school was, you have English and grammar where you learn words and how to use them and structure sentences and paragraphs and just kind of master the English language. You have, literature where you learn about writing or all that kind of stuff in a different way, and even culture to a degree, different cultures. Then you also learn, science. You learn social studies, which is just kind of like in school. Unfortunately, it often ended up being presented as just like facts for you to remember to write down on a test properly. But math is different. Math is, I heard people when I was growing up refer to math as like the language of like the universe, essentially. And it really is. I say all this because I know that math oftentimes is kind of like despised by people. Math is notoriously seen as like the most difficult subject to learn. But in fact, it is like perhaps in some ways the most profound, because everything runs off of math. Everything does. These days, we have all these different devices, these computers and smartphones and tablets and earplugs and so many other different type of things that are like absolutely built on math principles. They were made using calculations. The transistors and all those type of little electronics that are on the inside of the bigger electronics are just running calculations and things like that. Many different types of calculations. I think about Katherine Johnson, who a lot of people know these days as the lady they know from that movie Hidden Figures, and she's one of the computers who worked with NASA to help the astronaut, what's his name, John Glenn, to orbit in space, orbit the planet, based on the fact that she verified that calculations made by one of their devices were correct in regard to helping to make sure that John Glenn's space capsule would have the right trajectory. All that was just pure math. Pure math. Another thing is, I was doing some research, creating one of my calculus tutorials recently, and I came across something that I realized I didn't really learn in school, which is hyperbolic functions, which are just like trig functions, sine, cosine, tangent, and so on. But it's like hyperbolic sine, hyperbolic cosine, hyperbolic tangent, hyperbolic cosecant, hyperbolic secant, and so on. And the hyperbolic means it's related to a hyperbola, which a hyperbola is essentially like, well, I can't draw it here, but a hyperbola is like almost like two sideways parabolas. Like a parabola is like this, it just kind of goes like that, but a hyperbola is shaped like that, two, almost like two parabolas that are like pointed this way, if you kind of follow what I'm saying. But anyway, my point is, orbit behaves that way in space, where basically if you put like a satellite in orbit, then it follows a hyperbolic path, And scientists and engineers know how to, based on that pathway, they know how to get something out into space and orbit around the Earth so they can be thrown out into space. It's profound. The main thing I'm saying here is, I mean, even as an engineer, I couldn't possibly get into all of those details because it's a lot for me to like really understand, you know. But math is really extraordinary. Everything is running off of math. Even the fact that, you know, we all know that, gravity is something that essentially rules us all. It doesn't really matter who you are. Gravity is 9.8 meters per second squared. You know, like people always say, if you were to, get on the Empire State Building and just jump off or whatever, gravity is 9.8 meters per second squared. Or if you jump off of a step, gravity is 9.8 meters per second squared. It's literally that pull toward the center of the earth. It's a mathematical constant. I don't know. So I don't know if this will help, whoever's watching this to really kind of like consider math and like look at it a different way in school. I don't know if that's going to really help you to do that. But what I want you to understand is math is not merely something to just get a grade on in school. Math is like, it really is like the language of creation. It's like that background language. People also call it the universal language. It doesn't matter if you're in America or in, Nigeria or China or wherever. Math is math. It's the exact same thing that just kind of rules, so to speak, rules us all. And if you can really see that, you can kind of understand how math is so much bigger than school. Even just the concept of, for example, compound interest. Compound interest is the, the math behind having a certain amount of money invested, and then that money grows over time. And time is really in the favor of a person who's investing, because compound interest with time makes a little bit of money get bigger and bigger, and then as it gets to a certain size, and it really blows up. It blows up. So compound interest is really just kind of a profound kind of concept in and of itself. But it's all math. If you can kind of like get past the whole doing it for a grade part, then you understand that math is really extraordinary. Whether you're like an engineer like myself, or a physicist, or an economist, or an investor, or an accountant, or a math teacher, so many different other applications, or, like a programmer or something like that. So anyway, just kind of understand math is really extraordinary. It's really, really, really cool stuff. And if you ever get a chance, it might help to learn more so about how math is used in the world. Rather than just looking at your book and doing problems. If you're ever interested, just see how the math behind your smartphone. Okay, look that up. Okay, and I don't know, see what you find out. Be curious. Okay.